Hi. So taking a look at the paper in 2008, going to question 11. So question 11 gives us two integrals and asks us to evaluate them. So let's start with the first one. Well, it's simply the integration of a polynomial. So we can do that simply term by term. So that's equal to, well, integral of x is half x squared plus 1/4 x to the 4 plus 1/6 x to the 6 plus 1/8 x to the 8 between -1 and 1. Subbing in, we get 1/2 times 1 squared is 1. So every term is going to be simply their coefficient, so it's just the power of 1. So 1/2 plus 1/4 plus 1/6 plus 1/8. Minus, well, we notice that we actually have only even powers. So the -1 squared, or 4th, or 6th, or 8th, is still going to give you a 1, because the -1 is going to cancel. So that's simply minus, 1/2 plus 1/4 plus 1/6 plus 1/8. And we notice that is 0. Okay. Now, let's think about quickly why that might be. It might be quite interesting. So we have a odd-powered polynomial. And let's think about, for example, the graph of a simple lowest power polynomial. So we can go for the graph of y equals x, for example. That will go through the origin like so. Or the graph of maybe y equals x cubed. So that comes up like this, flattens off, and comes up. Now what you notice, if you do the integral, which is the area between a negative value and a positive value, it's the same modular, so 1 and -1, 2 and -2, you actually get the same area above and below, but one positive and one negative, so it cancels off. So you have a simple polynomial like this. It's going to be symmetric about the origin, and so you're going to have the areas cancelling off if you integrate it between a negative and a positive. That's just an interesting side note. But anyway, part B. Well, that looks intimidating, but in fact that should be over 11 there. But in fact, what we can do is we simply bring the 11 out the front. We know we can bring a constant out the front. So that's equal to 1/11 times the integral from 0 to 1 of x to the 9 plus x to the 99 dx. And well, that is just simply a polynomial integration. So x to the 9 becomes 1/10 x to the 10. And x to the 99 becomes 1/100th x to the 100 between 0 and 1. Well, that's equal to 1/11 into, 1 to the 10 is still 1, so that's 1/10, plus 1 to the 100, still 1, 1/100. And then the 0 clearly cancels. So that's equal to 1/11 times, well, 1/10 is 10/100, so 10/100 plus 1/100 gives you 11/100, so that is the answer of 1/100, or 0.01.